If you've looked at the SIMD notes, you'll know that I'm very high on prefetching as part of SIMD because otherwise you are fetching and multiplying so fast that it runs ahead of the cache loading. And so you're not really getting the full performance unless you prefetch as well. And I wanted to show you how to do it. It's not something I'm expecting you to do, but I thought there really should at least be some information on it. So yeah, we talked about this. Um, you have to ask for the prefetch at the right time so that just the moment you need it, you see it arrive. Now, unfortunately, there is no universal standard for how to ask for a prefetch. It is compiler specific. Maybe someday the world will come up with a universal way of asking and we can all build it into the code, but for now, no. So in G++, it looks like this. This is actually two underbars here. And you tell basically what you're doing is you're telling it what address do you want me to prefetch. Okay, so let's say that we were doing something like this, A equals A plus B, and we're doing it for this array size. So this is something I was playing with, but for every 16 floats, that's what that mod is looking for, it's going to ask to prefetch, well, PD ahead. And by playing with this, I found I got good results with 32. So go 32 floats ahead of where we are now and prefetch that. And playing around with that, it seemed to give pretty good results. And same thing with the B array because we need them both. The function for G++ has some extra arguments, and those are basically hints. Okay, so this one, A, we're going to read and write. B, we're going to read only. If there are certain advantages in the hardware for knowing that, and I don't think right now there are, but if there was, that would tell this function to do something special. You're giving us a hint about it. And locality is how far are these things apart in memory. So that's what it looks like in G++. In the Intel compiler, it's actually a pragma like this, and then there's this prefetch call, and it actually looks very much like the prefetch call in G++, except it's got these pragmas. And the pragmas, you're basically telling it what you're trying to do. Okay, you are prefetching a certain variable. Um, there are certain prefetch registers, or you're allowed multiple prefetches going on, and you're telling it which one you're using, either prefetch 0 or prefetch 1, and you're telling it how far apart or how many iterations ahead to go prefetch. So yeah, that'll work. If you're in Visual Studio, it's got something else entirely, but it's still the same idea. You're giving it a memory address to go get. It just doesn't have hints. And so here we go. We've got the prefetch, and we're saying, yeah, let's go 32 floats ahead. So no matter the compiler, it's the same idea. It wants a memory address, and it will go prefetch that cache line. Okay, and the effect on SIMD computations, I tried it with this and without this, using the assembly language version here. And you've seen this before in the SIMD notes, but here's what I got. And non-SIMD, the prefetch didn't make that huge a difference, but with SIMD, it made quite a difference. That is, no prefetches here, with prefetches there. Yes, it was able to keep the SIMD mechanism much busier with the prefetch. So if you've got a problem that can really take advantage of the SIMD, then you really need to look at prefetch as well.